Today we're going to be looking at bisectors and triangles. So the perpendicular bisector theorem states that if a point is on the perpendicular bisector, of a segment, then it is equidistant from the endpoints of the segment. The converse of the perpendicular bisector theorem states if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of the segment. So let's take a look at example 1. AC is the perpendicular bisector of DB. So that means it creates our 90-degree angle and it's equidistant from that point. And DB is the perpendicular bisector of AC. So that also means that they are equidistant from each other. So we need to find all the missing segment measures. So we know if this is 12, we know this one is 12. This length is 5. So that length is 5. If we take a look, we also can tell, since these are they're all congruent to each other, so we also know that all of these are 13. Based on side, angle, side. 1295, 1295. So then we know all the triangles are congruent to one another. So let's take a look here. If the measure of angle ADC is 28 degrees, we want to find the measure of the angle EAD. So we want to find this angle right here. So I'm going to redraw that triangle. I know this is 90 degrees because it's the perpendicular bisector. We're trying to find this angle, and I know my whole angle over here is 28 degrees. But since we're looking at the perpendicular bisector, I know that it's cut in half, so this is 14 degrees, so each one of those little ones. So in order to find that third one, I know 90 plus my 14 plus x, three angles add together to be 180 degrees. So 90 plus 90 plus 14 is 104 equals 180. So if we subtract 104 from 180, excuse me, so 180 minus our 104, we're going to end up with x equaling 76 degrees. So that's the measure of angle EAD. Alright, look at the distance from a point to a line. It's the length of the perpendicular. So it is the length of the perpendicular segment from the point to the line. The angle bisector theorem states that if a point is on the bisector, of an angle then the point is equidistant from the sides of the triangle. Sorry, of the angle, not triangle. So the converse of the angle bisector theorem states that if a point in the interior of an angle is equidistant from the sides of an angle, then the point is on the angle bisector. So let's use the angle bisector theorem. Remember that stated that if a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So we want to find the measure of angle QST. So since this is our angle bisector, QST is also 17 degrees. And then to find the measure of angle TSR, the whole angle, so 17 plus 17, and the measure of angle TSR equals 34 degrees. And our angle bisector bisects the angle, cuts it in half. So let's find NEF and the measure of angle DF and E. So find N. So if we look at these, we know these two are congruent to one another. So we have 3n plus 3 equals 19 minus n. So if I add n to both sides, 4n plus 3 equals 19. If we subtract 3 to both sides, 4n equals 16. When we divide both sides by 4, n equals 4. So there's our first one. So now to find the length of EF. EF, remember, is 3n plus 3. So since we know n is 4, 3 times 4 is 12, plus 3. So the length of EF is 15. Now to find the measure of angle DFE. So to find this angle here, I know this one's 20 because it's my angle bisector. So in this triangle, I know I have 90 degrees plus 20 plus the one I don't have. So 90 plus 20 is 110 degrees. So when we subtract that from 180, that angle is 70 degrees. So now let's take a look at example 4. The measure of angle TSQ is 4x minus 5. TQ is 6y. And QR is 8y minus 7. We need to find the values of both x and y. So let's start with x. X is with our angles. We know this is an angle bisector, which means it's cut in half, so they're congruent. So that means 4x minus 5 equals 15 degrees. So I can add 5 to both sides. 4x equals 20. Then divide both sides by 4. X equals 5. So now to find our y, we know these two segments are congruent. So since they're congruent, we're going to set them equal to each other. So if I subtract 8y to both sides, 6y minus 8y is a negative 2y equals negative 7. Divide both sides by a negative 2. y equals a positive 7 over 2, or the decimal form would be y equals 3 5/10.